Hi, I'm Carl Bradbury from Pico Technology, and this is the Pico Scope 5000 series flexible resolution oscilloscope. So what does flexible resolution mean, and why do we recommend the 5000 series as a great mid-range general purpose oscilloscope? Well, at the heart of all digital oscilloscopes is an analog to digital converter, and with all A to Ds there are two key specs: sample rate and vertical resolution, and there's always a trade-off between the two. It takes more time to sample a signal with increased resolution, and so sample rate will fall as a result. In the digital age, the development of oscilloscopes has been driven by the need to capture ever faster data rates, and so low resolution 8-bit scopes became the standard, providing fast sample rates but at the expense of vertical resolution. 8-bit scopes are fine for digital signals, where the main concern is to determine if bits are ones or zeros, but it can be frustrating if you need to visualize low-level analog effects, and as mainstream electronics is a mixed signal world, it's often the case that engineers need their scope to be optimized for both digital and analog signals. The Pico Scope 5000 series resolves this by allowing the user to select the optimum resolution for the job in hand. For example, selecting 8 bits at the highest sample rate, great for capturing fast data signals, or up to 16 bits at reduced sample rates, which would be ideal for visualizing low-level analog effects. So let's take a look at a live signal now using the Pico Scope 5000 to see how increased vertical resolution can provide insights into signals that can't be seen with an 8-bit scope. Here we have a 1 kHz sine wave, and though it's not easy to see, I've introduced a 100 kHz interference signal that's sitting on top of the sine wave. So next I zoom in on the sine wave to get a clearer view of the interfering signal. Now the 5000 is currently set to 8 bits vertical resolution, which allows for fast sample rate at 1 gigasamples per second, but only with 256 digitizing levels over the full vertical range. There just isn't the resolution required to make out any detail on the signal. However, if I now select 16 bits resolution, the detail of the interference signal becomes clear. Notice that the sample rate has dropped to 62.5 megasamples, which is the highest sample rate in 16-bit mode. If a higher sample rate was required, then adjustments in vertical resolution can be made as needed. Now, we say that increasing the vertical resolution brings a corresponding improvement in the dynamic range of the oscilloscope. So what does this mean, and how can I show this? Dynamic range is the ability to see low-level signals in the presence of high-level signals, and is often measured in dB. To show this, I'll reduce the interference signal until it's no longer visible in the time domain, even in 16-bit mode. And then I change the display from the time domain to the frequency domain by selecting spectrum mode on the oscilloscope. The spectrum range is set to 200 kHz, and here we see the 1 kHz sine wave very clearly, but the 100 kHz interference is lost amongst the harmonics, and that is typical of FFT with an 8-bit scope. A quick measure using the rulers shows a spurious free dynamic range of about 63 dB, which is also confirmed using the automatic measurements. Next, I select 16-bit mode and see what a difference it makes. The harmonics fall away now, leaving the low-level 100 kHz signal clear to see despite being over 70 dB down on the main signal. In fact, the usable dynamic range is close to 90 dB, which makes the 5000 series ideal for using spectrum analysis to identify and characterize low-level signals and noise sources, or quantifying levels of distortion in amplifiers, for example. For more information on the Pico Scope 5000 series, visit our website at www.picotech.com. Here you can use our distributor finder to link through to a local reseller who will be more than happy to advise further. Thank you for watching.